Hey guys, Rich here. I'm going to do a little bit of performance tweaking on the Kubota tractor today. So I had a BX before this one and I raised the hydraulic pressure, got a good bit more lift out of it. I want to do the same thing on this one, but I want to actually measure it this time first. When I say measure it, I mean the actual lift capacity, not the hydraulic pressure. We're going to measure that too. And the way to do this is underneath this hydraulic distribution block right here is there's a spring and a plunger inside of here that basically controls at what pressure the hydraulic fluid can can essentially bypass, as opposed to continuing to be fed through the hydraulic line to whatever implement you're trying to move. So let's get this warmed up. Let's get this down in my driveway where the rest of my tools are and get this guy out. And I'll show you a trick to limit the amount of hydraulic oil that we're going to lose out of there, and it doesn't involve a vacuum. There's actually a vent underneath the seat. I'll show you that. So let's get this out of here, let's get this warmed up, and I'll bring you back. All right, tractor's warmed up. What I've done is I've moved the forks to essentially the closest position that they lock in at, with the trailer receiver in the center. I know I weigh all my implements. This guy weighs 275 pounds with the 42-inch forks on it, which is what's on here, and 100 pounds just the frame. So I'm going to take a couple measurements. The key one, I think, is going to be 24 inches out from this point here, because the standard pallet is 48 inches in this direction. So if you assumed an evenly loaded pallet, essentially the measurement of 24 inches out would simulate lifting an evenly loaded standard size pallet. So got a couple things here to be able to do that. Got my crane scale, got a choker chain with a couple of anchor shackles, tape measure, and a 4x4 block to put across the forks. So let me get this all set up and I'll bring you back. Oh, I forgot to mention, what we're going to try and lift here is, this is essentially the stump / root ball of a pretty good sized shrub. I don't expect to be able to lift this guy straight out of the ground. If we do, that's fine. You can see I've cut it back. I'm going to dig this out with the backhoe today anyway. I don't expect to be able to lift this straight up. I kind of hope I can't. Otherwise, it's not going to be a good thing to anchor on here to measure. But if I do lift it straight out of the ground, no problem. All right, I'm all set up here. I didn't end up using that choker chain. I used a different chain. I had the choker chain set up on here, and I took a close look at it, and some of these links are really, really rusted. If you pull back the chain and you look at the part of the link that it'd be rubbing on, between the rust and wear, this guy is like half the thickness it originally was. So take a look at your chains, guys. I picked up a whole pile of these at a farm sale years ago, and they were cheap. This one probably should go in the trash. I might just keep the hook off the end of it for something else. But we're all set up here. So this is essentially the lowest I can measure with this setup, because the chain takes up a certain amount of distance, and then the height of the crane scale, and then the couplers. So let's see where we're at here. So we are, it's just about, by the time I put a little bit of lift pressure on this, it's probably going to be right about 24 inches off the ground. So figure this is lift height at, lift capacity at 2 feet off the ground. And we are 24 inches out on the fork. So this is going to represent the lift capacity of a full, well, sorry, not a full pallet, of a standard size 48-inch deep pallet, evenly loaded. So left a little bit of tension on this. I should be reading something. Yeah, so got 140 some pounds of tension. That's going to slowly leak down. We get the camera set up in a tripod, and let's see what she'll lift. Again, this is stock pressure. This is a Titan frame that weighs 100 pounds, and a set of 42-inch forks on here. Let's give this a go. pretty well. What I'm going to do is I'm going to re-rig this now to be what I would consider to be loading height, because 2 feet off the ground, that's certainly carry height. That's more than enough clearance to pick something up and move it around your yard. But I would consider loading height to be more like waist high. I think my dump trailer is definitely lower than that. I think any trailer is probably lower than waist high, but a pickup tailgate might be closer to waist high. So let's get a measurement at waist height. All right, we're set up here again, and this time we're at what I would consider to be loading height, which is, I've measured this at 36 inches. I think it's unlikely you're going to be loading something that is, higher up than 36 inches. So let's get a measurement here. All right, so I think that went well. Looked like it was still over 1,000 pounds, which at stock pressures, I'm actually a little bit surprised. I kind of expected this one to be under, probably closer to 850. So keep in mind, the fork frame in these 42-inch forks weighs 275 pounds. So at standard pallet size, if we subtract the frame and the forks here, we're still well over 1,200 pounds, probably closer to 1,300 pounds. What I want to do now is, I'm going to take a couple more measurements actually. In fact, I want to swing this thing around and measure the backhoe lift as well. But before I do that, I want to pull these forks off and just get a measurement right from the frame itself. That'll be kind of closer to the pivot pin measurement. But with the frame on there, which represents, still you could lift from there. You're going to be pretty close to the tractor. But from a load perspective, I don't see any harm in lifting from that fork frame itself. It's still a pretty rigid piece of material. So let's get set up for that. All right, so we're set up here on just the bare fork frame, and this is about as low as I can measure it with this setup. The bottom of the fork frame is about 20 inches off the ground. So I left just a little bit of tension on there to make sure my setup looks good here. So let's give this a go. That one kept going up. I was a little worried we were actually going to pull this guy out of the ground. I think I saw about 1,800 pounds there. So if you've got just a bare fork frame and you're trying to get something out of the ground, yeah, even at stock pressure, and we're a distance off the ground here that is enough to be able to rig something up. That's quite a bit of lifting force. All right, let me spin this guy around. I want to see what the backhoe will do for lifting as well, kind of using the backhoe as a crane. All right, so I actually had a heck of a time measuring that. The first measurement was the boom, and that was easy. But when I tried to measure the dipper stick lift, it's actually, the boom essentially goes into overload, and the boom starts to come down. I think what's going on there is it's exceeding the max pressure on the bypass for the boom cylinder, and it's essentially just leaking down past that bypass. The highest measurement I got was lifting with the dipper stick, and at the same time holding the lift valve on the boom. That seemed to help a bit. Maybe just the increased flow comes up a little bit past the bypass pressure. I'm not sure. It was really difficult to get a measurement curling the cylinder, because it seems like both the dipper stick as well as the boom would would bypass or move a little bit as I was trying to curl, at least at this height. Now keep in mind, I mean, you know, generally you're digging with a backhoe below ground. Here we are, this measurement is about 24 inches off the ground. But I saw, I think, about 1,200 pounds in there, so I think you could assume, you know, you should be able to crane something, you know, essentially out of the ground, you know, at the height to drag it over the side of a hole or whatever, in about the 1,200 pound range. I'm not going to try and measure this any higher. It's tempting, but just given how hard that was to measure with the different things going into bypass, I'm going to stop here. And I also don't think that the bypass valve that we're going to shim is going to make any difference on this backhoe. I think it has its own bypass. So I might not even measure this again. I just kind of wanted to get an idea for myself if I needed to crane something in or out of a hole, you know, about what the capacity is. You know, is it 500 pounds? Is it 1,000 pounds? Is it 1,500 pounds? And it looks like I can safely assume, you know, anything 1,000 pounds or under, I should be able to crane with this without issue. All right, let's go bump up the pressure. All right, first thing we're going to do is measure our pressure here before we make any adjustments. And it does not matter which one of these lines you take off. You could use any one. I'm going to take the blue one off just because I think it's going to be easiest to get to. And it's important that you don't have any pressure sitting on this. So the first thing that I'm going to do is just take the loader handle and just drop it through a quick 360 rotation to make sure I don't have any significant pressure there. And I'm going to try and do this without getting hydraulic fluid everywhere, because anything that gets all oily just tends to collect dirt and turn into a sludge. Let's get that line off. Let's get this guy on. And make sure it's locked all the way on there. Take the extra second. Just make sure that that guy's locked. The last thing you want is this thing flying off of there. All right, let's get this started up and measure. Oh, I'll put a link down below to what I bought to measure this. You can buy a whole kit, but it's cheaper to just buy the individual pieces and you're getting a better gauge. This gauge, the percent accuracy on this thing is substantially higher than the ones I've seen in the kits, and it is also exactly the range that I'm interested in. You see this one goes to 3,000 psi. I'm expecting our stock measurement to be probably somewhere around 2,200, and my target on this is somewhere between 2,500 and 2,600. So, but there's three pieces. There's the quick connect hydraulic fitting, there is a brass adapter, and then there is the gauge itself. I'll link all three of these below in the video description. So, all right, let's get this started up and measure. So I'm going to raise my RPMs to be right about what the PTO is. Like it was about halfway between the 2,000 and the 2,500, so that would be 2,250, which is, I think that's really close to, actually might be right on what the stock setting for this guy is supposed to be. So, all right, let's get a shim in here. Watching a couple other videos that are out there, I think Bodatrack did one. He had a similar stock measurement. I believe he had it a 0.2 shim, brought him to 2,600. So I'm just going to start with the 0.2 shim, assuming I have one. But before I do that, let me show you what we're going to do here. If you flip your seat up, and this is an L2501, it's 2018. I'm not sure what other tractors this applies to, but if I flip the seat up, I've got this rubber thing that looks kind of like a question mark here. This is a vent for the hydraulic, essentially the hydraulic tank in the tractor. And there's a little hole in the end of this guy. And if I find the screwdriver with the right size shaft, if I block off this hole, I think we're going to lose very little, if any, hydraulic fluid. The last time I did my filter on for the transmission and hydraulics, I blocked this guy off, and it was barely a dribble. I didn't have to use a vacuum cleaner. So I'm gonna go find the right size screwdriver and get the right size tools to take off the fitting on the other side of the hydraulic block, the hydraulic block, and I'll bring you back. All right, I found a screwdriver that does a perfect job plugging up the end of this this vent here. Fits in nice and snug without overly expanding it. And use a Phillips head, not a flat head, so you're not gouging up the inside. And I am set up on this side. Again, this is where we're focusing down here on this hydraulic distribution block, and underneath here we're going to be removing this bolt. This bolt is actually a special bolt that has a spring and a plunger on it, and underneath that spring we can add and remove shims to control at what pressure the hydraulic fluid bypasses as opposed to being fed to the implement. So I'm going to get you set up on the tripod, and we'll get this off. All right, I've got a pan down here. Again, I don't expect to lose a whole ton of hydraulic fluid here. If I do though, that's just fine. When I changed the filters on this, I expected to lose more because I kind of wanted to get some of the Super UDT2 in to reduce the whine on this guy and make it a little bit easier to run in the winter. But I hardly lost any. So if I just by chance end up losing a bunch doing this, I'm not gonna sweat it. The guy is not tight. I should probably check at what torque it's supposed to be in there with a torque wrench for when I put this guy back in, but it was not particularly tight. Alright, moment of truth. Yep, and there's my shims all came out. Alright, we're definitely still dribbling, but that's okay. Get all this in my pan here and get into the garage and take a look at what we've got. Alright, hopefully you can see. So it looks like what I had here is 3 shims. Oh, no. 1, 2, 3, 4 shims that are sticking together a bit there underneath the spring. So the way that this stack up goes is sort of this cup, the shims go down in the cup first, then the spring goes on, and then this sits on top of that spring. So like I said before, I'm gonna add a 0.2 shim. I've got a whole assortment here. These are really cheap. If you're going to bother ordering them, I would say just order an assortment. And I'm going to be careful here to make sure that as I put this back together that these are all clean. Looks like I do have a little bit of dirt. Alright, hopefully you can see. So it looks like what I had here is 3 shims. Oh, no. 1, 2, 3, 4 shims that are sticking together a bit there underneath the spring. So the way that this stack up goes is sort of this cup, the shims go down in the cup first, then the spring goes on, and then this sits on top of that spring. So like I said before, I'm gonna add a 0.2 shim. I've got a whole assortment here. These are really cheap. If you're going to bother ordering them, I would say just order an assortment. And I'm going to be careful here to make sure that as I put this back together that these are all clean. Looks like I do have a little bit of dirt on there that I picked up somehow. I'm going to count them. 1, 2, 3, 4. Alright, so as you can see, this guy is barely dripping. I think that initial amount that came out is probably just what is in either one of the lines or just this hydraulic block down here itself. I've still got just the screwdriver in the vent, and you can see how slowly this is dripping. So I wouldn't worry about a vacuum cleaner, you know, or having a huge bucket or pan here. If you block that vent like I did up under the seat, after that initial bit rushes out, it just drips like this, super slow. I didn't pay attention to exactly how much came out, but I'd say it was probably about maybe, I don't know, a cup, maybe 2 cups, absolute tops, maybe even less. So let's get this guy back in here. Now this seals, or it looks like it seals with a an O-ring on there. So I don't think the tightness of this or the torque on this bolt is going to be of particular importance. But I am going to go look it up quick and just make sure we get it right. If by chance the tension on this bolt does have an impact on the bypass pressure, I want to make sure that we have it right. So I'm actually going to pause right now, go check on that, and I'll come back. All right, I looked it up in the factory service manual, and it is 39 Newton meters. So I've got my torque wrench set to that. I'm not sure how critical that is. Like I said, this is sealing with an O-ring, but it is compressing that spring, I think. So it could be quite critical. All right, here we are. 39 Newton meters on that guy. All right, let's fire up and see what we get. So I'm barely seeing a difference there. So what I'm wondering is if maybe this bolt was actually in a little bit tighter from the factory. I don't want to go past what I have it torqued in there at. So I think what I'm going to do is pull this apart again and put a larger shim in there. All right, I've taken it back off, and let me tell you what I think is going on here. This is the page out of the factory service manual for adjusting this. And I don't know if it's going to show up on the camera, but it talks about tightening torque of 35 to 44 newton meters. I'd chosen 39 as just kind of a nice midpoint, or 26 to 32 pound-feet. And the threads on that are quite fine. So I think, even though it doesn't mention it here, I think that is what gives you the final adjustability. And I think this guy was just tightening a little bit more from the factory than where I had it, meaning I was essentially losing the benefit of that shim, or only getting a small difference. I went back and I looked at the videos. There was a small measured difference, but not as significant as I was expecting. It also tells you pressure change per 0.1 millimeter, shim approximately 38 psi. So, you know, I was basing the difference I was expecting to see on that other video that I'd seen. I think the tightening torque on the bolt when Botatrack did it just must not have been the same as factory spec. Because, I mean, you see, we really should have only expected a rise of 38 times 2. So I think what we're going to do is measure these shims. I'm going to find the 0.2 that I put in, or actually I'm going to find what the total stack up here is without the 0.2, and then figure out what my stack up should be to hit a target of around 2600, and then we'll fine tune it, hopefully with that range of tightening torque up here. So let me find the 0.2 first. Okay, this one looks like 0.8. Get hydraulic fluid on my nice micrometer. It's another 0.8. Looks like a 0.3. These are all actually slightly under, but I don't think the precision on these is tremendously high. That's another 0.8. And this one is, interestingly enough, that's probably the 0.2 that I put in, but it's actually reading a little bit large. Huh. All right, so all these are definitely, those three there are definitely 0.8. This guy reads, I guess I could take the measurement at this center. There might be some springiness in there. 0.272. 0.261. So I think these are probably both 0.2 shims. So let me calculate this and see what I would want to add here. All right, I did the math on that, and assuming I want to get to 2600 from 2250, I need about 0.92 millimeters of additional shim here. So I added, let's see, so that represents where I was at stock. This is 0.2. I've got some 0.4s here. Interestingly, these 0.4s don't have a hole through the center, but based on how this stacks up, I don't think that's going to matter. And these are genuine Kubota parts. This guy should be 0.4, 0.436. I wonder if maybe these aren't hyper accurate because these aren't even shims. Maybe these ones that are 0.8 are more of a standard washer. I don't know. So let's see, these two together. .67. Let's see what happens if I go with another 0.4. Probably going to end up over it's giving me 1065. All right, let's try getting rid of. All right, I did the math on that, and assuming I want to get to 2600 from 2250, I need about 0.92 millimeters of additional shim here. So I added, let's see, so that represents where I was at stock. This is 0.2. I've got some 0.4s here. Interestingly, these 0.4s don't have a hole through the center, but based on how this stacks up, I don't think that's going to matter. And these are genuine Kubota parts. This guy should be 0.4, 0.436. I wonder if maybe these aren't hyper accurate because these aren't even shims. Maybe these ones that are 0.8 are more of a standard washer. I don't know. So let's see these two together. .67. Let's see what happens if I go with another 0.4. Probably going to end up over. Yeah, it's giving me 1065. All right, let's try getting rid of the 0.2. Instead going with a 0.1. Come on out of there. We need you. .963. Hey, that is really close, especially if we come down a little bit on the tightening torque on that bolt, the lower end of the range. You see if one of these 0.2s was thicker than the other, I don't remember. Yeah, these things have a little bit of wave to them. As the measurement varies as I go around. That one's roughly 0.215. Yeah, so we already had the thinner one in there. We're going to give this a try. It's quite the stack up. I measure this just for the heck of it. Okay, that's right at 39. Let's check it again. Look at that, we're pretty much right on the money. It's just under 2600 at the RPM I showed you. I bumped the RPMs up just a bit and it came up higher. So what I might do is just give that guy like another Newton meter of torque and see if that sort of theory is confirmed if our measurement comes up a little bit. So I think I'll do that. I'll bring you back. All right, now we're closer to the top end of that torque range that the service manual gives. Let's see if it makes a difference. went up just a little bit higher, and I don't know how accurate that torque wrench is either. But at 2,500 RPMs, I've increased my throttle limit on this machine up to like 2,650. So I know if I go to 2,500 RPMs, I'm hitting right at 2,600 PSI, which I know is fairly safe on these machines. I mean, you know, use your own judgment. I'm out of warranty on this anyway. You know, that is definitely beyond the spec listed for the 2501, and actually a little bit past the spec, I believe, for the same size frame tractor with a different motor in it. I probably should just look at what the factory service manual says. There is some little bit of you know, range above and beyond what this guy was set at, so we might still be within spec for this size frame tractor, just with a larger motor. But yeah, so I am I'm happy with that. I'm gonna get my line reconnected here, and we'll get this guy back up at that stump and measure. All right, so we're starting with that test that should basically show the maximum lift capacity here right from the fork frame. This is kind of the most ideal condition, and we're as low to the ground as I can measure it. I think that ended up being about, with the fork frame being around 19 inches or so off the ground. And I did tear this out. I did zero the scale. That's just, I put a little tension on it just to make sure I was centered over top. So let me get on, start it up, and see what we get. This might go beyond the range of the scale. Guess we'll see. A lot of tension on that. Let's see, did we move out of the visibility window? No, I don't think we did. Our chain actually broke through part of the stump. I thought we were going to lose it all together. I should not have had my hand that close to it. I didn't think I'd left that much tension on it. Let me back this up and take a look at what we hit. All right, so I just took a look at the video, and we did not get a great measurement there. I think what happened is, because this lifted up, now we're measuring at a higher height than we were before, so it's not a fair comparison. I'm going to see if I can get this chain tightened up around this bush again, and see if we can get more comparative measurement. Even higher up, even after this thing slipped and was higher up, it was lifting more than what it did before. But I want to try and get a like for like. Alright, well, unfortunately I can't get it down quite as low as I had it before, so this is not going to be apples to apples, but I think the more important measurement is going to be the one coming up, and that's 24 inches out on the forks. So let me do the best job I can getting this one, and let's move on to that one. Yeah, I just checked the video. I didn't see a big difference there. I think, unfortunately, no matter how I rig this now, because this this stump has actually started to lift up a bit, I can't duplicate the height that I measured at before. But it is still higher. I don't remember exactly what the number was. I think it peaked into the 1800s before. Looks like we got to almost 2,000 pounds this time. So let me get set up and take the more important measurement of, you know, what we could expect to lift on a pallet at 24 inches, and then also at loading height 36 inches. All right, took quite a bit of re-rigging since this stump has slipped up a little bit, but I believe we're rigged up here for the 24 inches out on the forks and 24 inches up. All right, that was a nice usable increase in lifting power. I'll take a step back here so you can kind of see what this setup looks like. And at the end there, what I did was I used the curl, and when I used the curl before I bumped up the pressure, the curl had less lifting power than just lift. So, I wonder if maybe the increase in pressure kind of puts the curl cylinder over some kind of a hump where it becomes more effective. I'm not sure, because we got, when I was curling, we got well over 1,400 pounds, even 24 inches out at 36 inches up. I've lowered it a bit now to take the tension off, but it was just above, with a little bit of tension, it was a bit below 36. With a good amount of tension, it was above 36. And also worth mentioning, at this pressure, my back wheels stayed on the ground. At no point did it feel light. Now, I always have the BH77 backhoe on here, which is quite a good counterweight, and that's one of the reasons why I pretty much always have it on, except for in the winter when the snowblower is there. But that was kind of one of my concerns going into this, like, hey, okay, so am I going to get more lift, but is it, not really going to be usable without maybe picking something up heavy with the backhoe bucket just for additional ballast? My tires are not filled either. These are just air. So there you go. 1600 PSI on the bypass with not loaded tires and BH77 backhoe. Stability is fine, at least on level ground. And with the curl, we got over 1,400 pounds. So I say with the curl there, that's important because you can cheat a little bit. I used to do this on my BX. If you can curl a bit more than you can lift, you can curl down very slowly while lifting at the same time to change sort of the moment of load on the forks, and then curl to bring it back up, and just keep repeating that if you need to. But I think we were, before that, just with straight lift, I think we were high 1200s, low 1300s. I'll post a table here at the end comparing the lift before and after the pressure change. But that's pretty good. Don't forget, the forks and the frame weigh 275, and again, this measurement was 24 inches out from the back of these forks. So that means, setting aside the weight of a pallet, we know we can easily lift a pallet with 1,200 pounds on it, and probably a bit more if we cheat to loading height. So thanks for watching, guys. Hope this was interesting. I've been waiting to do this pressure increase until I had the time to measure before and after. I kind of feel like stuff like this, if you don't know what difference you made, you're just kind of increasing your risk a bit. Why? But I'm happy with this increase. This is still certainly not a forklift, but being able to lift 1,200 pounds centered on a pallet, to load and unload height is pretty good. I think we were around 1,000, maybe 1,050. So I think we gained essentially 200 pounds of lift capacity, or around about there. by doing this mod. And I feel like I was a bit conservative here. I know a lot of folks just go right to 2700. I almost kind of wish I did go a little bit higher. I was expecting the back to get a little bit light on this guy and maybe have to, again, add some additional ballast. But I'm going to stay at 2600. I think that's a very safe number on this machine. But yeah, thanks guys. Take care. Hey guys, I know I already signed off there, but as I was editing this video and put together the chart that you're seeing on your screen now, I was surprised by a couple of these numbers. You know, as I did the math. First of all, the lift increase was a bit higher than I thought. 238 pounds at 2 feet off the ground, 2 feet away from the fork backs. 222 pounds, 3 feet high with the same 2 feet, you know, forward of the fork backs. So that's about a 21% increase on average there. And the reason that surprised me is because we did not raise the hydraulic pressure by 21%. And I just kind of assumed that there was a direct relationship between these numbers, just based on a couple things I've read and just, you know, based on, I guess, basic logic. I am certainly not a hydraulics engineer. I know very little about, you know, how to calculate those pressures and stuff like that. But, you know, it kind of made me question, you know, did I do something wrong here? Is maybe my measurements wrong or something like that? So I dug in a little bit deeper and I took a look at the specs that Kubota publishes for this loader, the LA525, on both the L2501 and the L3301, which is the same as the L3901 from a specs perspective. And I'm going to switch your screen over to the spreadsheet that I used to build this chart and to do these additional calculations. So first of all, let's take a look at the pressure change that we made here today, and that was, we started at, you know, 2,230 psi and increased to 2,590 psi. I had said 2,600 even in the video, but when I reviewed the footage, it's just a hair under. So we increased the hydraulic bypass pressure by 360 psi, or 16.1% from our original set point. Well, therein lies the surprise, right? Because we only increased the hydraulic pressure by 16.1%, but we got a 21% performance increase. So the specs that Kubota publishes on this loader for these two different tractors, on an L2501, the pressure is 2275 psi stock, and on the L3301, L3901, it is 2347. Again, these are what the published specs. No, neither one of these tractors are going to be exactly like this from the factory. You see mine was actually at 2230. I don't know if that's a change in tension in the spring over time, or, you know, just the factory got it close enough, right? But either way, there's a 72 psi difference between the two spec sheets, or a 3.2% increase in hydraulic pressure setting between these two machines. Now they also publish lift capacities for this loader on either one of these machines, and I took one of the figures, sort of a middle of the road figure, being 500 millimeters forward, 500 millimeters high between the 2501 and the 3301, and that is 1135 pounds versus 1182 pounds, or a 47 pound increase. Well, that represents a 4.1% increase in lift capacity based on only a 3.2% increase in PSI rating between these two machines. So that's a factor of 1.3. And interestingly enough, if we take the 16.1 PSI percent, or I'm sorry, not PSI, 360 PSI, but 16.1% increase that we made to the PSI today on my machine, and we multiply that by a factor of 1.3, we end up with 21.1. Pretty much dead on our average 21% increase over here. So that gives me some peace of mind, you know, that it's not a one-to-one relationship from a percentage perspective when increasing the hydraulic pressure, and, you know, what to expect from a lift perspective. So I thought that was interesting. Again, thanks for tuning in. I hope you found this interesting or useful, or both. I appreciate if you did enjoy the video, please hit the like button. Even more so, if you want to see more stuff like this, hit the subscribe button. as well. It takes a lot of time to shoot a video like this versus just doing the actual work without videoing it, and it takes just as much time to edit it. So really appreciate it. Thanks, guys. Take care.